What up, y'all? Happy Tuesday. Go Dogs award just for you guys since you can't hear me in real class. It's me and Miss Koehl. We are going to be actually doing a co-teaching, like 10-minute video on some enrichment lessons for area of a triangle. Some of this more upper tier, higher advanced questions. And Miss Koehl is about to kick it off for us.
Okay, let me share my screen. Perfect. So we're looking at a complex figure, right? So we got two triangles right here, and they are on the outside of this square, which I will color in red for Coach Siegel because I did the others in orange for Tennessee.
Yes,
Two is better than one, but it's okay. So in order to find the area of all of this, let's first start with our square. So the area for a square is side squared, or side times side. So we have 12 times 12, which is 144 feet squared. So in order to find the right triangles, we learned today that the area for, oh no, we don't want red anymore, we want orange. The area for a triangle is base times height divided by 2.
Miss Koehl, can we stop there for a second?
For sure.
What I want you guys to do is I want you guys to click pause in the next 5 seconds, and I want you to actually work out this question first. Pay special attention to what is the actual height of the triangle. Is it 13 or is it 12? Look back at your notes, but click pause in 3, 2, 1, and pause. Welcome back. Miss Koehl is going to work out the area of the triangle now.
Okay, so hopefully we all realize that the base of our triangle is 5 feet. So let's plug in 5 feet for our base. Now, like Coach Siegel said, we have a 13 and a 12. However, we know that 12 is going to be our height because it is on this dotted line that makes a right angle, which is our perpendicular line. So we'll plug in 12 for our height, which we have 5 times 12, which is 60. Had to do some mental math there. Divided by 2, and I'll draw an arrow because I ran out of room. 60 divided by 2 is 30 feet squared. So we have our area for one triangle. However, there are 2 triangles in this problem.
And what's the vocab word that describes 2 triangles of the same dimensions? Do you remember, Ms. Koehl? Starts with a C.
Composite.
Congruent.
Congruent.
That's all right. Doesn't even matter. So remember, both of these triangles are congruent. So we have 2 congruent triangles, which means we can just add or multiply 30 times 2 in order to find the area of both of those 2 triangles.
I was looking at my notes, I would have remembered that important C word of
Look at you referencing the notes. Yes, ma'am.
However, that's why I have Coach Siegel here to help me out. So I took my 30 feet squared and multiplied it by 2 because they are congruent. And they are also mirrored, right? We can see that we have the 13, the 5, the 12. So like I said, multiply it by 2, but we cannot forget our Georgia red area of our square. So we're gonna just add him. Don't forget your units. And you should come up with your answer, which is
204 feet squared. Now, another way that you could have solved this, we're not going to do this for the sake of time. We know y'all don't want to watch a 45-minute lesson, but you can also recognize that this shape, before we decomposed it, is a trapezoid. So you could have also found the length of the entire base of the bottom. So you would do 5 plus 12 plus 5, which would be 22. And then the other base would be 12 up top. And then you would just multiply by half of the height, which is 6. And you would do 6 times 24. Oh, wait, sorry, 6 times 34, my bad. And I don't know what that answer is.
4, 24, carry the 2. 6 times 3 is 18, 19, 20.
204, which matches up our area that we originally got as well. So great. We are going to pause for our next thing. All right, y'all. So this next one says, how can we decompose this using triangles? So if you look at this, what is it? Hexagon, hexa 6, I think. If you look at this hexagon, you can see that there are a bunch of different vertices or points. So what I want you to do is click pause in this video here in a second. I want you to think about how many triangles can be built into this hexagon if we wanted to fully decompose it. You could also decompose this using trapezoids as well. Go ahead and click pause in 3, 2, and 1. Welcome back. Ms. Koehl is going to show you how we can decompose this.
Okay, so let's draw a straight line from point to point. Here we have 2 trapezoids, just like Coach Siegel said. We could break this up, but we're looking for triangles. So I'm going to connect each dot or vertice to the parallel opposite side. And look at that, it looks like a funky pizza.
And if y'all notice, there are 6 congruent triangles. We're really trying to hammer out that word congruency. Congruency means they are the same size and same shape. All the triangles are the same size and same shape, so they are congruent. Also, we would be able to find out what the area of this hexagon was as long as we found the area of one triangle. If it gave us the dimensions of just triangle 1, then we'd be able to find out the area of all of the other triangles by just multiplying the area by 6. So we are going to pause as we transition to our next question. All right, so this is one of those high level, level 5, really pushes your thinking questions on TN Ready that you may see, but probably not. But this is one of the most challenging examples you will see with 6th grade geometry. What your task is, you have to do 3 different things. The first thing I want you to do is find the area of the full rectangle. And Ms. Koehl right now is going to do her best to highlight the whole rectangle. So you're going to find the area of that massive rectangle. Make sure you pay attention to all of the dimensions. You're also going to find the area of the small rectangle she is outlining in red. And then you're going to find the area of this right triangle, which she's going to outline in blue. Go ahead and click pause. I want you to try it in 5, 4, 3, 2, and 1. All right, welcome back. So hopefully you guys figured this out. So there's some weird nuances to this question. The first one is, what in the world is the length of the base? I see a 7 for the small rectangle, and I see this weird chunk of 10 right here. Ms. Koehl, can you help me out? Let me know. How would I find out the area of the base of this triangle up top? Okay,
so you see down here that the entire base is 34 centimeters. From here to here is 34 centimeters. So we know that this part is 10 and this part is 7. So let's add them together. 10 plus 7 centimeters would give us 17. So if we have if our entire base is 34 centimeters total and 10 plus 7, 17, 34 minus 17 will get us this base that we don't know.
Wait, why did you subtract by 17 again?
Because 10 plus 7 at the top is 17, and our total base, again, is 34 centimeters, which is down.
Oh, yeah. So opposite sides of the quadrilateral or the rectangle are congruent. So because the bottom's 34, the top has to be 34?
Yep, because it's a rectangle, we can see that these two lines are parallel and these two lines are parallel.
Okay, so that makes sense. So you're saying B is equal to what?
What?
So the base of the triangle is equal to what?
So the base of the triangle would be 34 minus 17, right? Because the entire base is 34, and we need to figure out what this missing part is. So 34 minus 17 would be 17 centimeters. So
Good.
we now know that our base of our triangle is 17 centimeters.
I know a lot of you are thinking, no, it's 17 centimeters squared. No, because it is just the measurement of a side. It's not the actual area. Okay, great. So Ms. Koehl, and can you find out the area of the red rectangle first?
Of course I can, because what we have is our base and our height, right? So in order to find the area, we need to multiply our base and our height. So we have a base of 7 centimeters. I'll write it in here. And we have a height of 17 centimeters. So I will do 17 times 7 to find my area. Let me do some mental math. 7 times 7 is 49. So it's going to be 9, carry a 4. 7 times 1 is 7, add 4. It'll be 119 centimeters squared for our area of this rectangle.
The small rectangle, right?
The small rectangle. We have not done the big rectangle yet, but I have to re-highlight that because I erased it.
That's okay. So what's the area of the, how would I find the area of the big rectangle now? There's just so many shapes, I'm so confused.
You're right, there are a lot of shapes and a lot of non-straight lines. So, but we can figure it out because it's just a bigger rectangle. And again, we know that the area of a rectangle is base times height. So we can look and find our base of this entire rectangle, which we also just found up here too for the missing part, is 34 centimeters, right? Because 10 plus 7 plus 17 is also 34 centimeters up here. And it also is down here. So if we're finding the entire area of this big rectangle, we can do 34 for our base times our height, which is 17 centimeters.
And then will you actually set it up as 34 over 17 so that we can see how to do 2-digit by 2-digit multiplication for some of us that need a refresher?
Of course, I definitely need to do this like this anyways, because this is too big of numbers to do in my head, even though I could probably do it. But let's do it. 7 times 4, 28. We leave the 8 down here. Let's carry that 2. 7 times 3 is 21, and then add 2, 23. But then remember, since we're going over to our tens place, we got to put a 0 here. And 1 times 4 is 4. And 1 times 3 is 3. And we would add 238 to 340, which I'm just going to move it over here. 8 plus 0 is 8. 3 plus 4 is 7. And 2 plus 3 is 5. Which gives us a total of 578 centimeters squared.
Awesome job. And that is the area of the rectangle. And now let's find the area of that right triangle. Because I'm really, really confused on how to find that. I know what the formula is, but I really
What's
don't know
the formula?
I think it's base times height divided by 2.
That's 100% correct, right? Because a right triangle is half of a rectangle, which is base times height. So we're just taking the base times height and dividing it by 2. But we definitely know our base is 17 centimeters, right? Because we found that because 10 and 7 gave us 17, and we subtracted that from our total of 34 to get 17. So we know our base is 17. But what would be our height? We have this entire line, but we don't have a number here. But what we can see is that it is a rectangle, so our 7 for our base here would be 7 here. So that must mean that since both of these lines are parallel to one another, 17 would be our height for this height of our triangle as well.
Oh, so the height is 17.
And the base.
Okay.
We're getting crazy with all these 17s.
So 17 times 17, that's what we have to do next.
Yep, but you know what? This is getting a little much for my OCD brain. So we're gonna move this over here so everyone can see, because I'm losing control of math and all these numbers. All right, let's do some math. 7 times 7, 9, carry the 4. 7 times 1 is 7, plus 4 is 11, 119, carry the 0, or put the 0 in the 1's place because we're going over to the 10s. 1 times 7 is 7, 1 times 1 is 1. Add those together, 9, 8, 289. But do we stop there? Heck no, we gotta divide by 2. So 289 divided by 2, right? Because this is our base and our height multiplied together, but we need to divide that by 2 because it's just a triangle.
Remember, you divide by 2 because there's 2 congruent triangles inside of a rectangle or a square. So that's why we're dividing by 2.
Heck yeah. Now let's do long division, my favorite. 2 goes into 2 how many times? 1. 2 times 2 is 2, 0. Bring down the 8. How many times is 2 going to 8? 4, 8. Oh my gosh, I'm running out of room. 0. Bring down the 9. Uh-oh. 9 is an odd number. But I do know that 2 goes into 8 4 times. So 9 minus 8 is 1. I'm losing.
You just move to the side. It's okay.
So then we just got to do 10 divided by 2, right? Because we'll bring down this 0, and we had 1.
That's called annexing a 0. That's actually usually our first unit, but that's called annexing that 0.
Thank you for that definition. I didn't even know that was a thing.
Mm-hmm.
Annexing. Snazzy word. All right. 2 goes into 10 how many times? 5. So it is 144.5 centimeters squared as the area for our triangle.
So just to wrap it up for y'all, just remember the area of those small rectangles is 119 centimeters. The area of the full-blown orange rectangle is 578 centimeters squared. And the area of the triangle is 144 and 5/10 centimeters squared. All right, y'all, so this will be our final question, but the video is getting a little too long. I want you guys to be able to enjoy your day. What you can do is you can actually pause the video here. We're not going to talk about it today, but we just want to say we're so proud of y'all. Couple reminders. Make sure you continue on Schoology. Check your gradebook for missing assignments. Reach out to me if you need help with those missing assignments. Do your SEL check-in today and do your OneNote assignment. So I appreciate y'all watching this video. Hope that it was helpful, really kind of bumped up that rigor for you a little bit and gave you guys to really engage your brain. So thank you, Ms. Koehl. Shout out to you for finding these questions for us.
Of course. Shout out to you. And remember that congruence is the most important word.
Congruence, yes. We will see you guys Wednesday at some point in your class. Good job today, y'all.